All right, so we got this package. It's underneath this helicopter, and they tell us that the helicopter is descending steadily at 1.5 meter per second. So that means we have a V initial for the helicopter and the package, right? Because the package is attached to the helicopter. So V initial is negative 1.5 meter per second. Why negative? Because it's going down. Our sign convention is like this. Unless otherwise stated, there was a homework problem I was doing earlier today where I switched down to positive just because it was easier. If you want, you could switch the sign convention and say that down is plus. So in that case, you would make gravity, instead of gravity being negative 9.8, it would be positive 9.8. But here, let's keep it as negative. Down is negative, up is positive. So the initial velocity of the helicopter and the package is negative 1.5. Okay, then the package is released and it starts to fall. And the first question is, what is the speed of the bag after 2 seconds? So we're focusing on a time of 2 seconds. So for A, you go V final. Oh, and what's the acceleration? Oh, you know what? I think the book is right. I just realized something. Yep, I made a mistake. But I'm not going to make it right here because I already realized it. Okay, so I'm going to crush this. Okay, so the acceleration of the package. So let's make this real clear here. Here. So I'm going to set it up like this. So we're going to keep track of our data for the package, the package and the copter. Okay, so the time is going to be 2 seconds for the package, and it's also going to be 2 seconds for the helicopter. All right, what's the acceleration of the package once it's released? Negative 9.8 is going to be gravity. What's the acceleration of the helicopter going to be? 0. Because the helicopter, they tell us that the helicopter is descending steadily, meaning no acceleration. Just moving down at a constant speed. All right, so part A, what is the speed of the mailbag? So A, we're going to go VF equals V initial plus AT for the package. So V final. What's V initial for the package? Negative 1.5 plus, and then the acceleration for the package. The package is released, so the package is going to be accelerating at gravity. So this is going to be negative 9.8. And then the time is 2 seconds. Okay, so this gives us a final velocity of negative 21.1 meter per second. Notice the back of the book doesn't say negative, though, because what are they asking for? What is the speed? Speed doesn't have a direction, so you just say 21.1 meter per second. Okay, B, how far is it below the copter, below the helicopter? So I'm just going to delete this. So for part B, we got to do 2 calculations. The first thing we have to find, we need to find how far the package falls. And then the second thing is we need to find how far the helicopter drops. Because remember, the helicopter's moving and the package is moving. So how far does the package fall? X equals 1/2 AT squared plus V initial T. So we plug into this. And you could solve it with a different equation, especially since we know the final velocity, right? We now know the final velocity at the end of T equals 2. But this will work. So for the package, the acceleration is negative 9.8. The time is 2 seconds. And then plus V initial. You got to make V initial negative. 1.5 times 2 seconds. So this comes out as negative 16.6. Is that right? No? For the package, somebody saying no. Is that right? It's right. Crush it, Spaldo. Okay. So that's how far the package falls. Is that the answer? No. The next thing we got to do is find out how far the copter, how far does the helicopter drop? And the helicopter's moving at a constant velocity, which means it has zero acceleration. You know, so if you use the same motion equation, plus at squared, the initial t, what's the acceleration of the helicopter? Zero. It's not accelerating, so that's going to be v times t. So this is going to be 1.5 meter per second times 2 seconds. So the helicopter, oh, that's negative. The helicopter drops 3 meters. So the package falls for 16.6. The helicopter falls for 3. You know what? I take that back. I did do this right on my scratch paper. How far will the package and the helicopter be from one another? 13.6. The package and the helicopter, it's going to be the difference between those two values right there. So I say the package and the helicopter are 13.6 meters apart. The book says 19.6. Yeah.
Wait, for the first part on the x equals 1/2 at squared, why is that 16.6 instead of 22.6?
Well, let's see. Did I calculate it wrong?
Yeah, you did.
Hold on. Maybe I calculated it wrong. 4 times 4.
Because you never did the second part.
Oh, I stand. A. Spaldo is not crushing this. Correction here. Thank you. I punched this in wrong. You know what? The book is right. I stand corrected. Actually, this comes out to be negative 22.6. That's 3. So you know what? The book is correct. My faith in the book has been restored. So how far apart are the package and the helicopter? 19.6. Okay. Sorry, I hope that didn't confuse anybody. You good?
Wait, I only did one equation.
You can't do this in one calculation because the helicopter and the package have two different accelerations. The helicopter and the package have two different accelerations. Okay, now for part C, we're almost done. Shh. What are your answers to A and B if the helicopter is rising steadily at 1.5? So what we're going to do is we're going to change this. All we do is we change the 1.5 to a positive now down here. So this becomes a positive 3. And then what does it do to this calculation? Let's see here. So we got... So this comes out to be negative. So this, instead of this being 22.6, so now we're on to part C here. All you do for part C, for figuring out how far the package and the helicopter are, is you change the initial velocity to plus, which would make the helicopter and the package moving upward. Okay? So then instead of this being 22.6, it's negative 16.6. So, got to follow me here. So what is this? What is the negative 16.6 telling us about the package? The package goes down 16.6. So let's say that this x represents the start point. The package goes down 16.6. What did the helicopter do? It went up 3.3. So how far apart? Oh, I'm not 3.3. 3. It went up 3. So how far apart will the package and the helicopter be? Still 19.6. They're still going to be 19.6 meters apart. Okay?